1 second. The next problem, which I said is similar to, very similar to one of your assigned problems. This is on page 366 of the hardbound copy, so I don't know what that is on the softbound. There should be 2 pages on your softbound.
246.
246 on the softbound. Problem number 9. Problem number 9. Let's read this problem together, and then as we read the problem, we're going to identify, and this is now I'm preparing for, in preparation for developing the cost table. The labor cost to produce a certain item is $8.50 per hour. So let's put that here. Labor is $8.50 per hour. Job setup costs $50. Material costs are $20 per unit. The item can be purchased for $88.50 per unit. So we'll just put this here over here. Purchase cost per unit is $88.50. In fact, let me make these as dollars also. What else is given? The learning rate is 90%. That is, if they were to do this if they were to make this product in-house, that there is a learning rate of 50% of, so it says it's 50% of labor plus setup plus material. Okay, so that's the basic information provided by this problem. This is really a question of make or buy. Should they make the part, the item, in-house, or should they buy the item at a cost of $88.50? We are asked to determine the unit cost for 20 units. And given that the first unit took 5 hours to complete, so that's an additional information we need, T1 is equal to 5 hours. I'm going to name these cells so that when I create the formula, it will be easier to read. Oh, there's a $5. Okay, let me, thank you. Change that to just number. Click OK. There you go. So I'm going to highlight from B4 to C9. And formulas, create from selection. The names are in the left column. Click OK. Now, the comparison of make or buy will be based on, what is the average cost if you produced, so let's say if you produced 1 unit, how much will it cost you to make 1 unit? Can you do that by hand? Easily? Sure you can, right? Just compute the total labor cost plus the setup plus the material, and then multiply it by 1.5. That's your total cost of producing 1 unit. Compare that to the cost of purchasing 1 unit. Or, what if you want to produce 2? Or 3? Or 4? Or 5? So we will create a column here where we will compute the total cost of producing 1 unit, 2 units, 3 units, and so on and so forth. So the total cost of producing 1 unit is based on the labor cost, and then to that we will add the material cost plus setup, right? And then we will just call this overhead. The overhead, once again, is 50% of the sum of these 3 items. So if we added this plus this plus this plus this, we will have the 5th column as, we'll call this as the total cost to produce. Okay, are we clear so far? I'm just setting up the table here that we will use later on to generate the graph. But individually, you should be able to compute the material cost for, I need to move this up 1 row. Kind of tough to see here. So the material cost, how will you compute the material cost? It's the number of units that you're going to produce multiplied by this, right? Now before I do the formula here, let me create a name to this column, and I will call this N. Formula, create selection, and the top row is used as the name for that column, which is N. Okay, so I'm going to go back to F12, and I will compute the material cost. That would be this, or we can simply say N. Remember, we named that column as a number of units, N, times this cell, C6, which is material. All right? What number should I see here, if my formula is correct? 20, correct. $20. If I copy that down to 2, what number should I expect here? 40. All right, so this is functioning correctly. All right? How about the setup cost? If I were to only produce 1 unit, how much is the setup cost? It's 50. That would be the setup cost. Okay? How about if I were to produce in a batch size of 2 units? How much is the setup cost? No. The setup is a fixed cost. So that doesn't matter how many units you're producing, it stays the same. So the setup cost for producing 2 units is 50. It'll be 50 all the way. All right. Now let's go back and represent this cost in terms of a graph. Here's N, the number of units to produce. Here we will represent the costs. If we were to graph the total, starting with the setup cost here, how would we represent the setup cost on this graph? It's a fixed cost, right? So it has to be a straight line, horizontal line, like this. Okay? How about the material cost? What is the behavior of the material cost?
Linear.
It's linear, increasing, correct. So I will make this going this way. The slope of this line is how much? $20. So where will I put this line in this graph?
Below
Below the
the 50.
50? Over here?
A little lower.
Or it should be at 0, right? So this is, it really starts from 0. To something positive. So at 0 units produced, your total material cost is 0. And as you increase the number of units you produce, your material cost will increase by $20 per unit. Good. How about the labor cost? What do you think is the behavior of the labor cost here?
How much?
We know that as more units you produce, your total labor cost will increase, right? But what will be the behavior of the labor cost? Will it be linear? No. It'll be curve, right? It'll be curve. Which way will it curve? Now at this point, let me see if this works. So where will be the starting point for the labor cost? 0, okay, somewhere here. And we'll go like this?
No, it'll look like the natural log.
All right. Let's see if I can. It will be. Something like. Yeah, it's not cooperating. There you go. It's delayed by like 10 seconds. There you go. No. So yeah, it'll. Now I have two. Now it's gone. Technology. Well, you saw it, right? It has that curve increasing, but at a decreasing rate. Right, correct. Why is that so? Repetition, but more in particular, as you do this, as you produce more units, the labor unit to complete each additional unit gets smaller and smaller and smaller. Therefore, the total cost will also reduce. Something is happening here in this computer system. It's kind of funky looking. Okay. So how do we compute labor cost? Wouldn't we need to compute total hours? Right? How long will it take to complete the second unit? Or the first unit? The third unit? Once we're able to get the total hours here, we will multiply these by the cost per hour. To do that, we will use the same thing, same approach we applied to this earlier problem. We will compute the unit completion time, and then we will generate the cumulative total of this column. All right, so let's reconstruct that those two columns. And once again, let me copy this formula because this is the formula that we will apply. The unit time uses this formula, T1 times n raised to the power ln ratio divided by ln2. So the formula would be T1, what's T1? That's it. That's this one. Okay? Times n, that would be this, raised to the power, and I'm just applying this formula here, okay? Raised to the power ln, the ratio is, I don't have the learning ratio. So let me go back and let's put here the learning. Oh, no, I do. I mislabeled this. This is overhead. And I'll put here the learning rate. Of course, the name now will be incorrect. What's the learning rate for this problem? 90%? Let's see if I can rename these cells. Formula, create from selection, left column, okay. I'm going to replace all of them, so good. I think these are all good. All right, let me go back here. The unit time is equal to T1 times n, which is this, raised to the power ln, ratio is that, good, divided by ln 2, close parenthesis. There you go. So yeah, the first unit takes 5 units, 5 hours to complete. I should expect 5 there. If I copy this formula in C13 onto C14, what number should I expect? A number smaller than 5. But what exactly would that number be?
Well, it would be 4.5.
Yeah, what's the 90% of? That's right. You're right. And then if I copied this formula all the way down to 4, what should I expect in 4? N equal to 4. What? Yeah, 4.5 times, what is 90% of that? 4.02. 4.05. 4.05. So I know at this point that my formula for computing the unit time is behaving as expected, as properly.
You'd have to go down to 8 to get the 90%.
Right. Well,
Is that right?
to obtain,
90%.
Yeah.
4.05.
correct. Correct. Are we clear so far? We're not done yet. Remember, our objective, at least in developing column C, is to obtain the total hours. So we will just compute a running sum of column C. We'll start with C13, and then to C13, I will add the unit time for the second unit, and then copy this down. Are we good? We're clear?
The total hours, can I see the formula?
Sure. So the total hours is just a running sum. So what you're doing is you are adding the cumulative total, and then to that you add the unit. So for instance, in D14, the 9.5 is the number of hours to complete the first 2 units. And when you add the third unit completion time, that gives you 13.731, which is the total time of completing the first 3 units. Because we have the total hours in column D, we can now compute the labor cost. The labor cost is obtained by multiplying the total hours by the labor rate. So if you were only producing 1 unit, the labor cost there will be $42.50. If you're producing 2 units, that would be 9.5 times $8.50. That should give you $80.75. Are we good? All right, so let's copy this row all the way down to 28. Let's graph, how about these 2 columns? Let's graph material and setup using a line graph. That's exactly what we expect for the material and setup. That's how we envisioned over here. Cover that up. The labor cost can be superimposed onto this graph. You can do right-click, select data, and we will add another column. The range is from E12, including the name of that column, down to 40. Oh, sorry, that's the name. The name is labor cost. And the series value actually is from E12 down to here. Click OK. One more time. So this green line, there's a little bit of curvature there. It's not that pronounced, but you can see that there's some curve there. And that's because of the improvement in labor, meaning reduction in labor cost as you produce more units. So that graph is actually a total cost graph showing the 3 components: labor, material, and setup. How do we compute the overhead? Overhead, problem says, is based on 50% of, so we're going to multiply the overhead rate by the sum of labor, material, and setup. There you go, 56.25. 56.25 is the 50% of the sum of these 3 numbers. Total cost is equal to the sum of these 4 cost components. So if you were to produce only 1 unit, it'll cost you $168.75. If you were to produce 2 units, it'll cost you $256. Okay? Copy this down. The cost of producing 20 units is $1,606.24. That's a total for 20 units. The question asks, determine the unit cost for 20 units. So what should I do? I'm sorry? Exactly, the total divided by the number of units. So in column J, I'm going to create another column. We'll call this average production cost. So in other words, that's the cost per unit. Mary said, well, to compute the average production cost, you divide the total cost by the number of units you're producing. Copy this down. There you go. So at 20 units produced, the production cost per unit is $80.31. Is that cheaper than purchasing the item? Yeah, because purchasing the item costs $88.50. Let me recreate this total cost graph here. Let me delete this because we can create really a graph of the 5 columns here without adding more series. Insert line. Here is the cost graph for this problem. This curve is the total cost. Okay? And the green line is the setup cost. The red line is the material. The purple is overhead. And then the darker blue is labor cost. When you add all these together, you obtain the total cost, which is that. Now, in the assignment, I asked you to create this kind of graph as well as a graph that shows the average cost. Meaning, create a graph on this column. What do you think the shape will be for the average production cost column? It'll curve down. All right. So let's see how exactly it appears. There you go. Now, if I wanted to represent in the average cost graph the average purchase cost, we will add another column. Say in column M, we'll say this is the average purchase cost. What will be the average purchase cost if you were purchasing 1 unit? $88.50, right? We'll just pick up that information from C7. How about if you were purchasing 2 units? What is the average purchase cost? $88.50. It wouldn't change, right? Because there's no discount. So the average purchase cost will always be $88.50. We can compare this to this, right? So we can add this column onto the average cost graph. I'm going to add this is the average purchase cost. The series value is from here down to there. Okay. I will Because I included the name. I should not include the name. I'll put 813 there. Let me redo that. Computer is slow in responding. All right, so there it goes. There it is. The intersection point between the red line and the blue curve is around how many units? 9 and 10? Okay, so if you are going to need more than 10, the better approach would be to produce the part in-house. If you were needing less than 10, the better approach would be to purchase from vendor. Any questions? Now, since we have created this cost comparison problem using Excel, and the formulas, all the formulas in this cost table are linked to the basic information up here, you can now do a what-if analysis. You know, what if the learning percentage is really 80% instead of 90%? Cost will go down, correct. The average cost will go down. Why?
Takes less labor.
Yeah, I mean, the total hours the total hours column will have smaller numbers. With an 80% learning rate, the total hours will reduce. Right. So if you observed the average production cost, these numbers got smaller. Also, you will see that the intersection point between the purchase and the produce options has shifted from earlier it was around 10. Now it is around 6 or 7. What if the overhead were to change? Instead of 50%, it's really only 30%. How will that affect cost? Well, we'll go down. All right? So there you go. Easy.
When you get your final data, then you can see where your forecast was versus.
Oh, yeah, yeah. Any questions? Now is your chance to ask questions because we have 25 minutes left.
We have to create all this for the test?
Not for the test, for your assignment.
Okay.
Yeah.
This won't be asked on the test,
Well, I will be asking questions on this.
so you would want to do something like
You would want to do something like that, correct?
all that stuff.
Yeah, it would be nice. You can also compute by hand. Mark?
Will our benefit go up very much more if we stay for the next 25 minutes?
Probably not. So let's make like a baby and head out of here. Yeah.